about Central Salt and Marine Chemicals Research Institute, Bhavnagar. Now, why this institute was established? Let's first understand that India has a coastline of nearly 3,500 miles. It has inland salt sources which are present in Rajasthan, in the parts of Rann of Kutch in Gujarat, and then there are rock salt mines in the regions of Mandi, Himachal Pradesh. Now, all these have huge deposits for salt. Why do we use salt? Definitely, you would say for food purpose, but that is just one of those. Besides that, we also use salt for various heavy chemicals. For example, it is used as soda ash in the production of soda ash, in the production of caustic soda, in the production of chlorine, also in the packing industries as a preservative. So for food preservation, for canning, for packaging, curing, all those purposes, again salt is used. So salt is a very essential commodity, and therefore we need to have an institution where researches related to salt and marine chemicals could be done. Now, for a very long period, India was technically an importer of salt. The position deteriorated further, and the government wanted to establish that there has to be an institute where salt and related works could be done, and this was laid in 1940 that there has to be a department which was run under Dr. S.S. Bhatnagar, who was a salt research committee member, and he said that we need to formulate certain researches based on which that the import of the salt needs to be regularized, and the problems that we are facing for the shortage of the salt need to be resolved. Now, when there was the independence, at that point of time, most of the salt producing area went with the Sindh, and Sindh was in Pakistan. So during the time of partition, we had seen that a lot of salt producing areas went to Pakistan, which brought acute crisis of salt in India, and there were proposals by various expert members to enhance the production. So what happened in 1940s, the Salt Research Committee, as I said, was brought by Dr. S.S. Bhatnagar, and this was recognized by CSIR, which is the Center for Science and Industrial Research, the Council for Scientific and Industrial Research, and this was later amalgamated with the Heavy Chemicals Committee, because as I said, salt is also used in heavy chemicals. Now, this was reviewed in 1948 with Dr. Mata Prasad. Dr. Mata Prasad was the chairman of this committee. In 1948, a salt expert committee was established under Dr. P.A. Nariwala. Now, this committee had three important focus. First was to focus on more research related to salt and the work, bring in model factories which could actually increase the production of salt, and then establish research institutes or research stations which not only improve the quantity of the production but also the yield and the quality of the production. In 1951, Dr. C.C. Desai, who was the secretary of the Ministry of Works, Production and Supply, proposed that a Central Salt Research Institute should be established under CSIR. So in 1954, the Central Salt Research Institute, now known as the Central Salt and Marine Chemical Research Institute, was inaugurated by the then Prime Minister Pandit Nehru on 10th April 1954. So this institute in Bhavnagar came into place in 1954, inaugurated by the first Prime Minister of India, Dr. Jawaharlal Nehru. Pandit Jawaharlal Nehru. Now, why this was very, very important? Government of Saurashtra was saying that a land needs to be given. Now, government of Saurashtra offered a generous place that you can establish your buildings in Saurashtra. The only thing is, we required that the Saurashtra government would pay for everything, but the works have to be done. The institute has to be located within Saurashtra. So within Saurashtra, they were looking for various places, and Bhavnagar was one of the places which was identified. Bhavnagar at that time was considered as one of the flourishing centers for education and higher studies in the region of Saurashtra. And at that time, Raj Hotel, the premises of Raj Hotel, two bungalows and nearly 125 acre of land was given for experimental salt farms, and this land was given to CSIR by the government of Saurashtra, and government of Saurashtra offered that CSIR can establish the institution within the premises of Saurashtra and start their work for the salt experiments within the region of Saurashtra. So finally, this institute started in Saurashtra, in Bhavnagar. Now, this institute has 8 different divisions. There is around staff of 200 plus on rolling basis, along with the fellow and the project assistants, and 10 students are given internship every year in this research institute. So, what are the 8 different departments? We would understand each of the departments one by one. The first is Analytical and Environmental Science Division and Centralized Instrumentation Facility. Similar to the ICER that we have understood, Centralized Instrumentation Facility is the facility where all the divisions of the research institute have some common instruments which could be used by any of the divisions. Salt and marine chemicals, inorganic material and catalysis, natural product and green chemistry, applied phycology. Phycology is the study of algae, plantomics, membrane science, and process design. So those are the 8 divisions which were given. What were the major functions? As we said, increasing the production of salt, increasing the yield of salt, then working on seaweed. Since it is marine chemicals, working on seaweed. Seaweed is an excellent source of food and is in high demand in foreign nations. Also, focusing on renewable sources of energy, how you can work on membranes. So RO, reverse osmosis, the membranes for the reverse osmosis, how researches can be done to enhance those and bring in more salt tolerant species. So those are called as halophytes. With changing changing weather or the climate change, we have witnessed that salt tolerant species needs to be grown. So saline farming, as it is called as, could be one of the new options that could be discovered. So all those would be part of this research institute. Under the recent SciMago is the institutional ranking. Under this institutional ranking, this institution, the Bhavnagar Institution for Central Salt and Marine Chemical Research Institute, has obtained 8th place in the country among the 326 institutions that were ranked, and therefore it is also among the top 700 global institutions. The annual budget is somewhere close to 50 crores annually, and there are various research publications, IP rights which have been given to the research institute. So we understand each of these divisions one by one. The first is the Marine Algal Research Station. Now this has been established in Mandapam. In 1967 at Gulf of Mannar, we found that seaweed is abundant. So what 3 important seaweeds were identified? One is the Glaciaria edulis, which is known as agrophytes, and this has been cultivated using rope method in the Kurdasai island and has now been commercially cultivated. Geltila erecrosa, now this is using the coral stone method in the Irwadi coastline. Then we have Kapaphysis alvarius cultivation. This has been through micropropagation, and then commercial cultivation for this has been done. So 3 important varieties of seaweed explored through the Gulf of Mannar. We also have establishment of seaweed tissue culture laboratory. There has been indigenous facilities through which we have seen that these seaweeds have also been grown in the regions of Andaman. So 2 places, the Hathi Tapu and the Dundas Point, where seaweed cultivation has been promoted in Andaman. The next is plantomics. Plantomics means preparation of low sodium salt of botanical origin. So here we have the crop improvement for stress tolerance and managing the coastal ecosystem. So 2 important ideas. So for managing the coastal ecosystem, we are talking about carbon sequestration, nutrient cycling. For crop improvement, we are talking about characterization of the genes, plant genomics, talking about the plant growing bacteria which could be done. So various forms of biotechnology has been used, genetic engineering, biochemistry, agronomics, plant nutrition, all those have been discussed through this division, which is plantomics. And plantomics talks about specific research on halophytes. Halophytes are those species which can tolerate saline water. So how those saline water species can grow, probably how we can explore more avenues for saline farming, and how saline farming or halophytes can actually bring in value addition to the final products. The next is the analytical and Environmental Science Division, along with the centralized instrument facility. So here is the list of instruments that are there. So it talks about it basically focuses on electrolysis, electrocatalysis, optical sensors, supramolecular chemistry, instrumentation methods. There are various funding agencies for the same. Most of them are from India. So you have Department of Science and Technology, Ministry of Environment and Research, Research Board for Atomic Studies. Besides that, we have one from Croatia. From Croatia, Zagreb, we have the Ministry of Education and Science and Sports, which has been funding the Analytical and Environmental Science Division and the Centralized Instrumentation Facility in the institution in Bhavnagar. Then we have Applied Phycology and Biotechnology Division. As we see here, there are various things that can be done. For example, plant microbe interaction through molecular mechanism, biofilm formation, metabolic engineering, biopigmentation, metagenomics, genomics. Then we also talk about the the cash crops, the crop cultivation, the abiotic tolerance, the biotic tolerant species, the salt tolerant species. So various studies and biotechnological studies related to algae would be studied under this department. The next is the Salt and Marine Chemical Division. Now this talks about four different categories. One is salt, the other is marine chemicals, the next is social missions and basic studies. So the basic study talks about phase equilibrium, ion interaction, room temperature ionic liquids. Marine chemical talks about how potash can be obtained, sulfates of potash can be obtained, the low sodium salt, how it can be prepared, how magnesia can be prepared, green bromine, how green bromine can be prepared. Then when it comes to salt, we have high pure salt, which is through desulfation technique or crystal habit modification. Then salt morphology with or without additives. We also have the nutrient salt, which is fortified salt. Now fortified salt with iodine, with now we also have fortified salt with iron, specifically to check the issue of anemia in women and girls. Now we have basic studies, which we already discussed. The Extension Societal Mission talks about the various social missions being involved in the regions close to Gujarat, where the institution is. Along with that, there are also projects in the form of model salt forms, which are located in Rajasthan, Odisha, Tamil Nadu and Andhra Pradesh. There are various training programs and iodine kit estimation to understand the estimation of iodine in iodized salt in situ condition has been done. The next is within this division of process design and engineering, there are three different categories. One is process and product development, the other is waste to wealth, and the other is renewable energy. So under renewable energy, we talk about value added products which could actually increase the life, integration of solar devices for biomass generation. We also have thermochemical conversions of carbonious waste, which can be seen. Under the process development and the product development, we have salt fortification, which we already said, double fortified, which is iodine and iron, and the various techniques for enhancing the basic structure. Then we have the waste to wealth. Under waste to wealth, we separate carbonates of sodium and potassium for pharma industries. We separate ammonium chloride and sodium chloride for pesticide industry. We talk about organic pigments and how those could be obtained. We also talk about potash technology solution for sugarcane molasses, and those are based on various distilleries and how regulatory norms have been taken into account for the same. The next is green chemistry division. This division talks about value addition through seaweed polysaccharides, how new materials can be developed, finding out commercially important seaweed varieties and the polysaccharides which could be derived from those seaweeds, eco-friendly products which could be extracted from seaweeds, and synthesis of various hydrocyclic compounds through these seaweeds can be done. The next is the inorganic material and catalysis division. It has four divisions. So first is the specialty chemicals, catalysis, solid waste utilization and adsorption. Under adsorption, we have gas separation, the storage of methane and hydrogen. Under the specialty division, we have carbonate, zeolite, silica and calcium carbonate. Then we also have organoclay, metal oxides, layered oxides, and zirconia, which have been studied. Under catalysis, we have molecular catalysis, photocatalysis, and hydrogenation techniques which have been used. Under molecular catalysis, it is mainly isomerization, transesterification, the understanding the bonds and the bond transformation. Similarly, under solid waste, we categorize that into three different criteria. It is fertilizer waste, biomass valorization, and e-waste, spent catalyst. So recovery of the precious material from the e-waste, how it could be done. The next is the membrane science and separation technology division. Now this division talks about desalinization. How does desalinization occurs? It could be through reverse osmosis, ultrafiltration, nanofiltration, electrolysis, or so how it occurs? There are various ways. For example, brackish water RO desalinization, hollow fiber ultra filtration. There is two-stage RO filtration for seawater. Then mobile vans for desalinization. Electrodialysis, solar powered electrodialysis. We also have thin film composite reverse osmosis. So all those are the ways through which we understand that how water purification can be done, and technologies related to same can be enhanced. So far, India has 18% of the world population and 4% of the global water use, and therefore we say that by 2050 India could be one of the nations that could be a water stressed nation. In order to work that this water stress could be removed, we need to build in indigenous technologies where filtration of water and safe drinking water could be provided to the masses, and for which we require various membrane technologies which could filter most of the water with minimum wastage and also increase the pace of filtration. Now if we look onto the patents filed in India and abroad, there have been a significant number of patents which have been filed from this institution, and there are nearly 10 to 15 patents which have been filed in India, and 20 to 25 which have been granted recently, and then abroad as well we have significant number of patents, around 5 to 10 which have been filed. When it comes to research publications, there are around 221 research publications from this unit with an impact factor of 4.49. Now impact factor is the factor through which we understand the reputation of the journals in which the content is published. So the number of citations against your publication is indicative of the impact factor. Now the technologies used, as we said, under the salt and marine chemicals, we identify high purity, low purity salt, the low sodium salt, double fortified salt, IP grade salt. So those are studied under the salt and marine chemicals. Under inorganic and organic chemicals, we understand silica, zeolite, calcium carbonate, bromo compounds, biodiesel that can be obtained, ion exchangers, and bio-based chemicals mainly from agar. The next is waste to wealth. Now this talks about separating the salt from by various chemical processes, valorization, then talking about the precious metal, the recovery of the precious metal and recovery of lac from the effluent. From the marine biology, we talk about the pigments from the microalgae, biodegradable thin films that can be obtained. So those are some of the sectors and the technologies which have been addressed here. Now this institution itself has four important components. One is the intellectual strength of this institution, where the technological know-how, IPs, the consultancy projects that this institution takes with industry is known. Then the partnership, which is collaboration, technology validation, and solutions which are given to the partners. Services, which is mainly the instrumentation, environmental competency, and the infrastructural facilities. And then in terms of knowledge, there is a high opportunity with high impact research work which has been done here. There are various open days which are organized. Jigyasa, which is a science program, is organized to bring awareness in the students in the nearby areas. Chemistry of common salt and Britain products. Salt technologies are some of the topics which are currently addressed by this institution. This institution also works with some corporate social responsibility, mainly in the field of safe drinking water, rural development, seaweed cultivation, women empowerment, healthcare, and clean environment. As we already mentioned, there are maximum of 10 students admitted every year for the internship. The resource knowledge center, which is the library, is automated using the Alice for Windows EFW, which is the LS for Windows. Now, this is a international user-friendly library package. This allows online return and issue of the books, and this would provide speedy access to the bibliography, to the location and the information of the books and the content in the library. So that is through the LS for Windows, which is one of the softwares which is used in the libraries of this institution. So this was about the Bhavnagar Institute. We will be covering many important science research institutes in India. Wish you very good luck. Thank you.